Hello and welcome back as we continue our conversation around Algebra 2, Unit 6, Inferences and Conclusions from Data. I'm James Key here on the set of Homework Hotline Live, and I'm here with my colleague Brian Crane.
James.
Brian, in this segment we're going to look at how statisticians estimate a population mean. Could you give us some examples of situations where it might be important to measure that?
Certainly. Anytime you buy a product, no matter whether it's a bottle of soda, a candy bar, or virtually anything, the number that happens to be on that label, it'll say net weight, 3.8 ounces, or it'll say, volume, 1 liter, or the like. Okay, that is a number that hopefully represents the mean for the entire population of those items that are manufactured. In this case, if I'm a manufacturer, I want to make sure that that is actually the case. And again, when we talk about several million bottles of soda a day, it's kind of hard to actually take and measure 100 million bottles because particularly if I wanted to drink 100 million bottles, I'd be quite full. But it's not going to be particularly useful to do that. So again, we're going to need to take a sample. And in this case, a little bit different from sample proportion, we're actually going to be dealing with sample means used to estimate sample proportions. Again, it's probably the primary use that people that need to know about statistics really does need to know. You certainly can't say that if I weighed this bag or I computed the volume of this one thing or even a sample, that I'm not that I'm going to get that exact value.
So Brian, I heard you mention the fact that, again, using that example with soda bottles that are being produced and they're printing a particular value on the label and how it would be impractical. As soon as you go to do that testing of your product, you can no longer drink that product. And so I heard you mention the fact that they're going to take a sample as opposed to being able to do quality testing on every single unit that they produce. So with that, along with sampling, comes that uncertainty. And so the companies that manufacture sodas can't with certainty know what their actual mean is overall, and so they're having to resort to estimating that population mean. And could you just speak to us about how they go about doing that?
Okay, well, again, very similar to the proportion problem. We are probably just going to take one sample and use that to estimate the actual mean. Again, I'm not going to be able to do what we talked about in the proportion conversation, talk about maybe coming up with a sampling distribution by taking hundreds and thousands of samples of a certain size. So again, what we're going to do is we're going to take, let's say, 100 bottles. We're going to find the mean fill of those 100 bottles, if we're talking about 1 liter bottles, and then we're going to use that value and use a margin of error. Again, this is all basically related to what we talked about in the proportion discussion. But we're going to use that information to, again, determine an estimate for the mean along with a margin of error. Again, the assumption is going to be, either that the population itself is normal, and in most manufacturing processes it is, or that the sampling distribution is actually going to be normal. And it'll be one of those things that you can learn about in further statistics courses as to why sampling distributions are actually look normal after a large enough size. That's basically what's going to happen. We're going to do a similar thing we did with proportions, find a sample mean, compute a margin of error based upon the sample mean and a sample standard deviation, and come up with that margin of error.
Brian, in instruction in Algebra 2, students will see an activity where they're analyzing sleep data. We can imagine that people have been asked to record how many hours they're sleeping on average, and that they're reporting, if we look at the graphic here, imagine that they're reporting, in a lot of cases, somewhere around 8 hours. Some people are sleeping as many as 12 hours a night. Some people almost as few as 4 hours a night. And here we're looking at a sample where 50 people were asked to report that information. Brian, could you just talk a little bit about how, on the basis of this distribution of data for that sample, how would you actually go about estimating the mean number of hours that people sleep in a night?
Well, again, since we're dealing with a this is one sample. So basically these dots are not sample means. These dots are actually individual, data items. It's very important to understand this is not a sampling distribution of means, though it would work in exactly the same way. If I had a sampling distribution of means, we could do what we did with proportions. So what we're going to have to do here is we're going to have to take this data. It's a nice thing about the computer. The computer will do all this stuff for us very quickly. And in this one sample, we got a mean of 8.585 hours of sleep. So there's our mean. Okay, and that's the value we're going to use. We're going to say, okay, the population value is going to be somewhere around 8.585 hours.
And are you certain that that's the exact population mean?
Certainly I'm not certain. Okay, there is no certainty whatsoever about anything in statistics for the most part. So that we have, that value.
Is it possible that the mean is actually 12 or 4?
Oh, could be. Unlikely. But again, are we 100% certain of that? No. The mean is probably going to be, what that is. But that's, again, why we talk about a margin of error, and we have to apply the same ideas of margin of error, here, as we did with proportions. So in this case, we have a sample standard deviation from the data. It was 1.721. And so what we're going to do here is we're going to have a margin of error, just like we did with proportions. Formula is a little bit different in that the formula in this case deals with the 2, which is basically, again, our 95% level, 2 standard deviations. Or actually, we call that value a standard error, though it's not that important to know that term. But, again, we're hoping that we're normally distributed, so within 2 standard deviations, that's going to be our margin of error value. And so the standard deviation value we're going to use is the square root of the sample standard deviation given by S, okay, divided by the square root of the sample size, which in this case happens to be 50. So we simply do a quick computation. Again, we could do this by doing a sampling distribution, but in this case, it's, we have a nice, neat formula that the mathematicians have come up with, and eventually you learn how to do that if you take, some advanced statistics class. So whatever that value happens to be, and I don't know what that value happens to be offhand, I don't calculate square roots in my head that often anymore. Used to do that back in the day. But so whatever that value ends up being, James is computing that as we speak.
Let's see, the value of that whole expression
Yep.
is about 0.37.
Okay, so the margin of error is approximately 0.37.
And what exactly does that mean?
Well, that is our margin of error. So basically what we're going to do is we're going to use that in conjunction with our sample mean. So basically we're going to look at 0.37 hours on either side of that value. So for example, if I go to 0.37 below, that's going to be 8.215. And if we go to above, that's going to be 8.955. Okay, so this is a range at which we're probably 95% confident, again, I'll use that word, that the mean is actually going to fall in between. Again, this is not a sampling distribution, so, the individual data pieces, you'll notice, are much outside of that. Okay? But since we're talking about a sample of size 50, that 95% level is going to work. So again, just like when we talked about proportions, when we report this type of thing, we can't just say, and it's more egregious when we talk about population means, in that most reports with population means, what you will get is just that value. You won't get a margin of error like you normally get in reports about proportions. They'll simply say, well, the mean sleep time of Americans is 8.585 hours. And that's the number. You will, for a lot of time, you won't hear about a margin of error in this case. It's very seldom that you do when you talk about means. You should always be completely honest about what that means. And Again, 95% of these intervals that we construct this way will actually contain the mean. Are we certain? No, we're not certain at all. But that's what we're finding here.
Brian, thanks for that helpful discussion of how statisticians go about estimating a population mean based on sampling procedures and formulas that go along with the margin of error. In our last segment, we're going to go ahead and look at how statistics are used in reports and the kinds of things that readers should be aware of as they read those reports. We'll see you then.